Welcome to The InEVitable, a podcast by MotorTrend.
Hi there, this is The InEVitable. This is MotorTrend's podcast, our vodcast about the future of the automobile and transportation, and going with transportation, the future of boats and maybe airplanes and maybe big rigs. Yes, we're talking about hydrogen, and we're going to get there. But before we do, this guy, Ed Lowe, has a special message just for you.
The InEVitable podcast is brought to you by the all-electric Nissan Ariya, inspired by the future, designed for the now. And I don't think you have a question. Do you have a question?
No, I mean, we could reiterate what we said a couple episodes ago about how deregulating every single industry in the U.S. with the new administration might actually lead to faster hydrogen adoption, counterintuitively, because the goal is you want zero emissions, and that's, I think, Joe Pratt, who we have coming up. His business is Zero Emission Industries. You don't want to burn natural gas and produce CO2 with that to create hydrogen. You want green hydrogen from renewable resources. Well, just imagine all of a sudden that national desire, federal mandate to make green energy goes away. Okay, hydrogen's great. So you start burning natural gas and you make hydrogen, and then all the infrastructure's there. And then when the administration changes, when we get the next one, let's stop burning natural gas. We'll make hydrogen out of wind and solar. Boom, all ready to go. Just a thought.
I had no idea what he's talking about. But our next guest does, and it all connects. You can come back to it, rewind. We are talking to a hydrogen expert. He's got a PhD. He worked at Sandia National Laboratories, which is a big federally funded research lab. They do everything from stuff that you can't even talk about, space aliens, nuclear, all that stuff.
Yeah.
He is a fascinating dude.
He literally has a PhD in hydrogen.
Yeah. And he's the CEO of Zero Emission Industries. And they are doing, I thought this whole episode was going to be about this thing that we are not at all qualified to talk about, which is hydrogen-powered boats, but turns out it's a lot bigger. ZEI is looking farther afield, but they have done two very interesting marine products. They did a ferry, they did a power boat.
You'll hear all about
it. But again, the plan is world domination through hydrogen. So let's get into it with Joe Pratt, CEO from Zero Emission Industries. So Joe Pratt, CEO, Zero Emission Industries, thank you so much for coming out to see us.
Thanks for the hat.
Thanks for the hat.
Absolutely.
And,
I'm having a bad hair day. So.
Yeah, this is going to be interesting because we were talking just briefly, we're kind of a little over our skis here. We've had hydrogen folks on before with wheels, but this, I think you're officially our first Maritime, our first boat guest. And hydrogen is something we only dabble in. But tell us, what is ZEI? What is Zero Emission Industries?
ZEI is, well, first of all, thanks for having me here. It's really
thank
cool.
you. And by the way, sorry I didn't come take the boat ride. My wife's in Chicago, and my kid had a fever all week.
Oh,
so
no.
I was just stuck at home. Yeah.
No problem.
Yeah.
If you're available Monday or Wednesday.
It could be, yeah.
Okay.
All right.
We'll figure it out. We'll get you on there.
All right, cool.
ZEI is a hydrogen technology company. Our goal as a company is to bring hydrogen to the real world. So we do that focusing right now on hydrogen power systems. Originally focused on maritime as the primary use case, and that kind of goes back to my history working at Sandia National Labs and some other efforts there, and finding out, okay, hydrogen really makes a lot of sense in maritime, so let's start there. You could call that our beachhead, and now we see that the solutions we've developed for that are being sought after in other industries too, including on-road and land.
Why does hydrogen make a lot of sense for maritime?
For boats.
Yeah. 2 words, energy density. You can store a lot more energy in a hydrogen tank than you can in a battery. Mm-hmm. If we're talking about zero emission, right, you kind of have that fundamental assumption. If you don't care about zero emission, keep burning bunker
fuel.
Right.
The greatest.
Yeah.
Real quick, what's wrong with bunker fuel if people listening have never heard of this. What is bunker fuel and what's wrong with it?
Yeah, okay. So you get a barrel of crude out of the ground, and then you refine that, and you pull off things like jet fuel and gasoline and diesel. And
Nice stuff.
And what's left at the end is sort of this tar, right? And they just use that. They send it right to the ship and they burn that. It's so thick, they actually have to heat it on board to get it to flow through the pipes.
And so
into the
this
engine.
is like everything you purchase at Walmart comes from China on boats powered by bunker fuel. Not everything, but like 90% of it.
Yeah.
Okay.
Pretty much, yeah.
And it's horribly polluting.
Very much so. They've been interesting kind of emissions regulation trajectory in Maritime is, for 3,000 years of shipping, there's been none. And then starting around the 90s, they started increasing regulations. The first one was low sulfur. So the black smoke you see coming out of these big ships, a lot of that has to do with the sulfur that's in the fuel. So that was one of the first things they did. It's one of the reasons why maritime is a really interesting use case is we, through some of my old work, talking to these operators and just kind of understand that history, and you see that, okay, they've been having to deal with new regulations kind of every 5 years, and after literally thousands of years of nothing, and that industry is so slow moving, a ship lifetime is 30, 50 years, they're just not able to keep up. They're getting really frustrated. So they're looking for something like a fuel cell was really attractive to them because they can say, we are compliant with the current regulations and any potential future regulation. We don't have to worry about that anymore.
Right?
Yeah.
And not just U.S., this is globally, there's a lot of regulations.
Yes, for sure. Yeah.
Okay.
Going back to energy density, because you mentioned if you're looking at it from an emissions perspective, and if you're okay with emitting stuff, go burn bunker fuel. What is the how does bunker fuel from an energy density perspective compare to hydrogen?
That's a good question. I don't know the answer to that.
Okay.
We usually compare it to diesel.
Okay.
We'll
say diesel.
Yeah. So diesel is used kind of in the near shore stuff. And actually for US, there's certain, in Europe and whatever, there are certain zones along the shore you can't burn bunker fuel anymore.
And near shore would be like tugboats, fishing boats, Coast Guard stuff. Well, Coast Guard probably has no regulations, but
yeah, I don't know. It's a good question.
But police boats.
Yeah, police boats, ferries, tour boats, all that, recreational boats, burning gasoline, all that kind of stuff.
Right.
So that's really our near-term focus, and we can talk about that if you're interested why. But the gallon of diesel, and I think you've covered this on other podcasts, is kind of like a kilogram of hydrogen, roughly the same amount of energy. So if I tell you, oh, this boat holds, 1,000 kilograms of hydrogen, you can roughly equate that to 1,000 gallons of diesel.
Got it.
Yeah.
Okay.
And the hydrogen has a potential to be totally green. Not always, but it has a potential.
Right. Yeah. So that's kind of to me anyway, that's one of the cool things about hydrogen is we can make it today, and we do, roughly 95+% of hydrogen made today is from fossil fuel. Nobody's working in hydrogen to do that forever. They want to get to the point where we're making it from renewable power and splitting water, 100% green life cycle. But the cool thing is that we can get out there today and clean up these ships, these boats, these ports, these trucks, using whatever hydrogen we can. And as that green hydrogen becomes more and more available, we can make the switch, and the engine doesn't care. Hydrogen's hydrogen at that point.
I wish you could say that 20 more times in 15 languages and in 8 different voices, because that's the part that all the comments, all the negativity we get about talking about any of this, electric cars, electric bikes, whatever. They're like, yeah, but you're still burning coal to make the electricity. It's like, yeah. But you're missing the point. Like, we don't always have to be doing that. Like, we can get to a point where you clean the vehicles up first and then clean up the energy sources that you're using to, power them.
Or
right?
do both.
Right.
Yeah.
At the same time. Okay.
Yeah.
And critically, because Jonny kind of alluded to it, all the stuff you're Amazon priming 2-day shipping come from China. We get a lot of the people who give us a lot of grief. It's like, cars itself are just the smallest part, a very small part of the overall emissions load. Look at planes. Look at boats, look at shipping.
Boats are huge.
And it's true. Something I should try to tell my parents because they love to go on cruises and claim that they love the environment. I'm like, man, cruise ship industry, they got a lot of issues with all the. Do you see those giant smokestacks?
Yeah.
Like, what's coming out of there? So.
And cruise ships are diesel, right? Not bunker.
I think it depends where you are.
Oh.
Yeah. So it's again, it's global, right? Yeah. The marine industry is really interesting and complicated. There's things, a certain ship might be docking at the port of LA, but it's actually operated out of China, and then it has to follow the regulations from, Marshall Islands, right? There's all these different kinds of nuances that have to do with maritime law that can make that really difficult to enforce. Number one, what is the regulation that applies? Number two, who's going to enforce that?
And just to get back, I know we can move away from bunker fuel, but it's so disgusting. Like during the pandemic, we had all these ships stacked up off the coast of San Pedro in Long Beach. Yeah. And I was driving this Mercedes, the EQS, and it has, instead of having a frunk, they have this air filter, which I guess is huge in Beijing. You really want to filter the air, and it shows you the air quality coming in and what's coming into the cabin, right? So let's say it's I don't know, whatever the metric was, but it was 4 on the outside, and it was coming in at 1. And I was talking to a Mercedes engineer. I'm like, why don't you have a frunk? And he was explaining the importance of air filtration in China. And I remember I had been down, I was, I had a kid during the pandemic, a young kid, couldn't go to daycare. So I was taking him down to San Pedro all the time to look at the boats. And I was like, oh, the air's filthy down there. And I just started driving south, and I got to San Pedro, and it had gone from 8 by my house to 120.
Whoa.
And just because these boats are sitting there idling 24 hours a day, and they were just gross polluting, not CO2, just disgusting whatever is coming out, NOx, beyond NOx, because we don't burn bunker fuel anywhere else except for on the ocean.
Yeah, I wonder how much of that also was kind of, as you get closer to the port, a lot more trucks and port equipment and everything else.
Yeah.
This was just boats stuck in the harbor, so I think they were just sitting there idling,
Yeah.
Wow. But it's also...
It was crazy. It was just crazy,
There's a very well-publicized study in Southern California about how people who live along that 710 corridor...
710's horrible.
And depending on which way the wind generally goes, this direction, everybody on the other side of the freeway has much higher rates of lung cancer because of both the boats and the trucks that are taking all the goods off of the ships. But let's pivot quickly to, I want to talk about what you've been doing, the FCV Vanguard, and then where this is going with your portable hydrogen refueling system. But let's first talk about, should we talk about Sea Change, about this commercial ferry that you were involved in converting?
Yeah, sure. Wherever you want to start.
Yeah,
I'm here.
So what was Sea Change? What's the story there?
Yeah, so, there's, a longer and a short version. So I'll start with the short version. When I was at Sandia National Labs, I did a lot of studies on looking at hydrogen for maritime, kind of at the request of the DOE. So they said, does hydrogen work, outside of cars? Where can we find places? So that was one of my...
DOE is Department of Energy.
Yeah, thanks. That was one of my tasks, was to see, does hydrogen make sense in maritime? I didn't know the answer at that time. We had, and I started doing some work in that area, made a fuel cell generator that would sit at a port and create power for refrigerated containers, this kind of stuff, to see, okay, that makes sense. And then we had a private company go to basically knock on DOE's door and said, hey, I want my tour boat fleet to go to zero emission. I've heard about this stuff called hydrogen. Can you help me figure out how to do that?
What year is this?
2014, 2013.
Okay.
Yeah. And I was the only guy they knew who was working on this stuff. So they called me and said, Joey, go talk to this guy. Turns out he was in San Francisco, so it was super easy. But at that time, I was getting kind of a lot of phone calls. Probably once a month, someone would call and say, hey, I want to do a hydrogen-powered this. I want to do hydrogen. Would it work? And I'd go through it and say, and then they'd say, well, how much does it cost? And I'd tell them, and they'd be like, oh, never mind. Right. So I expected the same conversation once again, right? And I said, if you really want to reduce your emissions, probably just look at LNG at this point.
Liquid natural gas.
Liquefied natural gas.
So kind of anticipating where it was going. And he said, Joe, you don't understand. I don't want low emission. I want zero emission.
Nice.
And so I was like, oh, okay. So what are we talking about? So he told me about this boat he wanted to build. And at that time, I think the Toyota Mirai was just coming out. That was, and there'd been experimental fuel cell cars out there.
Yeah, Mercedes did some, and General Motors,
Very low volume,
Toyota. Yeah, very low volume.
So that was kind of like the state of the art of hydrogen fuel cell technology was like 80 to 100 kilowatt motor or fuel cell pack and 5 kilograms of hydrogen storage. And this guy was talking about 4 megawatts and, 2,000 kilograms of storage. And I just said, you're crazy. Like, that'll never work. And he said, no, it will work. You got to examine it. And so one of my colleagues and I sort of penciled it out on the back of a napkin and said, holy cow, this actually might work. So we did a study that got picked up kind of around the globe with people interested in greening up shipping. And it was all about, could this work? And if so, how would you do it? It wasn't just us designing a boat. We actually had a real naval architect who designed this thing using hydrogen fuel cells. And it's like, holy cow, this thing could actually make sense. So we started talking to operators. As I mentioned before, we'd talk to operators and say, this is awesome. How do I get this technology? And we found also that they had to sort of see it and touch it and feel it in order to really want to adopt it. Like, they didn't really just believe a paper from the DOE. Right. So we said, okay, we have to build one. We got to build one of these boats that really runs in commercial service so we can convince the world that this is actually possible. And so that ended up, we applied for a grant from California Air Resources Board, CARB.
Yep.
We won it. And then that's when I left Sandia National Labs and started this company. And that was our very first project. So that boat is now on the water. It's running as a ferry in San Francisco. Anybody can get on the boat and ride it. And it's our hydrogen fuel cell, technology, integrating different suppliers together to make it all happen.
It's a ferry. It's like
a ferry.
How big a boat are we talking about?
72 feet, holds about 80 passengers. The seating can change depending on what they're doing with it. So,
and what are the final specs of the tanks and the motor?
So that one has 242 kilograms of hydrogen stored at 250 bar, which is 3,600 psi, which is typical CNG pressure.
It's not that's not high for hydrogen.
No, but it actually, you can talk about why that it stores more hydrogen than you could at 700 bar or 350 bar, simply because the available tanks are bigger.
Right.
So we don't, instead of having like 30 small tanks, we're able to get 10 really big tanks, and that is
and how many kilograms was it? I'm sorry,
242.
Oh, so it's not 2,000 kilograms,
right?
Just, okay.
Yeah. So the study we did at Sandia, we called it SF Breeze. I don't even remember the acronym, what it stands for. The study we did was like
you got to have the acronym.
150. Yeah, right. My friend Letty at Sandia, we're really happy you said that because he made it up.
Good. Yeah. I know how important acronyms are to government work. Yeah.
That was 150 passenger, I think, like I said, 4 megawatts, and had, I think, 1 or 2 tons of hydrogen, 1 or 2,000 kilograms. But we couldn't build that. Our grant from CARB was only $3 million. So we had to scale it down, but still get it commercial. Try to find that sweet spot for what we could do with that money.
You took $3 million and you built a boat, or you bought a boat and converted it? Like, how does that even work? Like,
yeah, Maritime's another weird thing about Maritime is almost every like commercial type vessel is a one-off. There are certain designs that they will build, but there's like you hear it called like sister ship. It's never exactly the same.
Right.
And so you got to work with a shipyard, a naval architect, equipment providers, and you sort of put this design together, and then you contract it, and they start building it. Mm-hmm. Recreational boats are different. Right. Those are like stamped out more like cars, right? Yeah. Same thing over and over and over again.
So this is like a one-of-one ferry? Like the actual ferry design wasn't something else? Like
the ferry design, so we work with a naval architect headquartered out of Australia, and they are running in Sydney Harbor. They have kind of sister ships.
Okay.
Of course, not hydrogen fuel cell, but that's the design they started with.
Okay.
Yeah.
And then So we can go to San Francisco and hop on what's now called the Sea Change.
Yeah.
Who's the operator?
San Francisco Bay Ferry. So it's a public ferry service.
Huh.
We don't own the boat. We sold the boat in 2019 when it was still under construction. There was a company called Switch Maritime whose focus is low carbon, zero carbon ferry system. They initially started out looking at battery powered vessels. They still are, but they found that hydrogen gives more range, more flexibility than battery.
Is it similar to cars? Whereas, like, I was in London recently, and I saw a bunch of like small, like 4-passenger battery powered boats that you take out for like a picnic on the Thames. And like, with a car, hydrogen does work, but batteries actually work really well for like individuals to drive cars around.
Yeah.
But when you get to like a semi truck, that's a very big battery if you want full electric. But if you want to do a hydrogen fuel cell, is it similar with boats where just because when you scale them up, hydrogen just makes more sense?
Yeah, exactly. That was one of the questions that I had right before I left Sandia. Did another study that looked at, the question was, what is sort of that limit for batteries on boats? What is that limit for hydrogen on boats? I was expecting there would be sort of, you can go up to this scale of boat and then you have to just use diesel, right? Like you would top out. Surprisingly, I found there was no limit for hydrogen, especially when you use liquefied hydrogen. You can fit it, you can power a container ship, going from here to Shanghai with hydrogen fuel cells.
What's liquefied hydrogen?
Liquefied hydrogen is hydrogen that's turned so cold that it turns into a liquid. So it's like, yeah.
And so how does that store better than gas, compressed gas?
Oh, it's just more dense.
Oh, it is? Okay.
Yeah, more energy dense.
Liquid,
yeah. So liquid hydrogen is roughly 4 times fatter, bigger than diesel. So it's not as dense as diesel. It's about 4 times bigger, about 2 times bigger than LNG. Gaseous hydrogen, depending on your tank configuration and pressures, could be anywhere from like 8 to 15 times bigger than diesel, right? So you get a pretty significant volume reduction using liquid hydrogen. And on ships, volume is the biggest problem, not so much weight.
Right.
Really fast, small boats, weight becomes more important, like a car.
Yeah, but on a container ship,
yeah,
it's they already weigh volume. 1 million tons or whatever. What is how big? Because they're huge. How big is a modern container ship?
Oh,
like in terms of displacement and like weight.
Displacement, I don't know. I shouldn't even try to guess.
But like they're like 1,300 feet, right?
Yeah, exactly.
They're massive.
Yeah, they're huge.
It's like 4 football fields or something.
It's like a city, floating on water.
So the tonnage is just off the scale. I mean, it's just, okay.
The cool thing is the bigger the boat, the easier it is to do hydrogen fuel cell power, even without cutting into any of the cargo space. So one of the reasons is like a big container ship might have a 60 megawatt, bunker fuel engine in there, which is, this size, not this room, but the size of the building that we're in, like 4 stories tall.
They're 14 cylinder I've seen them. The engines are massive. They're 6 stories tall.
Yeah.
They're 150, 200 feet long. I mean, they're massive.
Yeah. And then they have to put them in these giant engine rooms, because if it breaks, you can't just like take it out and fix it. Like you have to fix it in there. So it's got to be in this even bigger volume room to have overhead cranes and all the extra equipment. With a fuel cell, imagine like a server room where everything is, or you've probably seen battery rooms, right? Just racks and racks of batteries, narrow corridors between them. That's what a fuel cell room would look like in that kind of scale. So imagine you could fill that whole gymnasium-sized engine room just with racks and racks of fuel cells. You could actually fit more power into that same volume, or lower the volume of that engine side using fuel cells than you can with diesel.
And then the motor
use that for your fuel storage.
And then it's just an electric motor, and so it's big, but not as big as a 14-cylinder. I mean, Google it if you're listening and you have access. Like Google 14-cylinder ship motor.
Yeah.
They're insane.
Yeah, they're pretty cool.
They're
actually,
cool,
I mean, as a mechanical engineer, they're pretty cool.
They're way cool, but yeah.
TireRack.com is your place for the best selection of tires from top brands. Always fast and free shipping and multiple convenient installation options. They also stay on the cutting edge of the tire industry. Their world-class tire testing program is truth serum for tires. EV-focused tires, products with noise-canceling technology, they've tested it all to help you make the best decision before buying. TireRack.com, the way tire buying should be.
So let's get back to like this this practical application with Sea Change. It as a boat, how does it compare to other commercial ferries? Like, is it across the board? It's better. Like
What's the downside?
Like range. Like,
Yeah.
is it comparable? Like, can carry the same number of people? And then I'd really like to know how does the operator refuel?
Mm-hmm. Yeah. So again, the Sea Change, I think, is unfortunately not a great example of the capability of hydrogen fuel cell because we were so limited in funding. We had to make some significant compromises on power and range. So today, compared to the other ferries in the SF Bay ferry fleet, it's slower and the range is good, but it's slower than they want.
Okay.
Right, which is why they have it in service just going along the San Francisco waterfront. They don't have it doing their long commuter runs that run at like 35 knots, right? This ferry typically runs between 10 to 15 knots along the waterfront. And that simply has to do with how much money we could put into it for the powertrain.
Okay.
In terms of fueling, that's one of the things that's kind of a cool story, I think. We, again, because of limited funding and limited timeline, we realized we couldn't afford to build a hydrogen fueling station on the water. And we didn't even know where the boat was going to operate when we started the project. So even if we said, okay, we're going to put in, $5 or $10 million and wait, especially building on the waterfront in California would probably take 5 to 10 years to get the permit.
Yeah.
Even if we wanted to do that, it didn't make sense for this. So we had to find a way to fuel the boat like they fuel boats with diesel today, which is you have the boat sitting there at the dock, a big truck of diesel shows up, the hose comes out, drops into the fuel tank, they sit there for an hour, and then they roll up the hose and they drive away, right? Zero infrastructure fueling. We had to figure out a way to do that with hydrogen, which is a lot harder because you can't just pour hydrogen from one bucket into another, right?
No smoking, folks. Right.
Yeah.
Right.
So
Fuel's also flammable, but go ahead.
and then there's Coast Guard regulations and everything else. And luckily, during my time at Sandia, I kind of taught the Coast Guard about hydrogen and how to engineer safety regulations around it. So I was very familiar with that side. So we invented a system where everything to fuel is on the boat. The boat shows up to the dock. A hose actually comes off the boat, connects to the compressed hydrogen fuel truck. And then a deckhand or captain with an hour of Coast Guard mandated training hits a few buttons on a touchscreen, is able to bunker, which they call fueling in maritime, 240 kilograms of hydrogen.
How long does that take?
It really depends on the truck, but it's been taking them from probably about an hour to an hour and a half.
And I'm completely ignorant. Is compressed hydrogen just available? Is the source like you talk?
Where do you get hydrogen?
Where are you getting the hydrogen for this?
Yeah, so hydrogen's been around 100 years. We've been using it as a commodity chemical in the U.S.
Industrial uses, hospitals.
Yeah, primarily in the U.S. there's about maybe 40% used for oil refining. So desulfurization and upgrading of crude to the products we use uses a lot of hydrogen. And then ammonia production for fertilizer uses a lot of hydrogen. Those are the two primary users.
Oh, okay. I always heard hospitals, but
yeah, I mean, there's other industrial users too. Semiconductor manufacturing, all other kinds of little stuff that uses hydrogen also. So there's the hydrogen infrastructure is in North America and most countries is built up pretty substantial. And if you look for it, you'll see the hydrogen trucks running around. People usually don't pay attention, but they're running around.
because they look like another truck.
Yeah, another, kind of industrial gas, nitrogen truck, that kind of stuff.
Right.
And the kind, because it's liquid hydrogen you're using. It's sort of readily available.
on the sea change, we're using gaseous
Yeah.
hydrogen.
Okay. Oh,
Yeah,
right.
but a lot of the, you guys know, California's got a whole bunch of hydrogen stations today. A lot of those are supplied with liquid hydrogen. So liquid hydrogen, because it's more dense, is more efficient to truck around.
Right.
So there's a pretty big liquefaction production facility in Ontario. A lot of trucks come out of there and they go, what do they call liquid hydrogen? The continental fuel, because they can go anywhere over across the continent. And then they'll gasify it if they need gas. A lot of the fueling stations are gas, so they'll take it there.
Literally means warming it up, right?
Warming it up, and then for things like the Maritime, pressurizing it.
Right.
Yeah. So in a liquid truck, it's maybe 100 psi, and then you need to liquefy it and get it up to, gasify it and get it up to 10,000 psi.
Is the Mariah's 10,000 or 5,000?
10.
10. Okay.
Yeah.
So it's
All light duty cars are 700 bar or 10,000.
Okay. Right.
Some of the older ones we're using 350 bar.
Right. There are
Transit buses typically are 350 bar, 5,000.
I remember driving this old Mercedes. It was a while ago now, but it was a Mercedes B-Class F-Cell. I want to say it was 350 bar.
It could be, back
and
then.
it was. I don't think it ever made it into production. It was, or if it did, it was gone after a year.
It's,
So
700 versus 350. Like, I like the lower pressure stuff. 700 gives you a maybe 10 or 20% advantage in volume over 350 bar, per amount of energy you carry. But the weight is worse for
because the
700
tank
bar.
has to be much
The tank
stronger.
is much thicker.
Yeah.
Yeah. Even carbon fiber, it's still pretty heavy.
Right.
So depending on what you're using it for,
Right.
some truck manufacturers, for example, on the Class 8s, Nikola's and whatnot, use 700, some use 350.
But I was going to say, Maritime, you're not nearly as worried about crash as you are. Because I remember I was talking to someone, they said, like, well, this 700, one of the advantages too is, like, in an accident, it's just those are ballistic tanks, basically.
Yeah.
You can't crack them.
Yeah, I think they still do it, but in the early days, all the tanks on the transit buses were on the roof. That's where they'd mount them up there.
Yeah, I remember
And
seeing
there's
that.
stories of, the bus ran into a low-hanging bridge and,
Bridge lost.
The bus is demolished. The bridge is demolished. The hydrogen tanks are fine.
Yeah. I remember somebody was explaining how overbuilt hydrogen tanks are for that reason.
Well, let me, related question. From a energy in, energy out sort of point of view, is, creating a heavy duty tank versus one that's not as thick or not as, shielded, and then, going from liquid to gasifying, like, is there a lot of energy, like, that you need to put into building these relative to the vehicle at the once it's kind of on the road? You know what I'm saying? Like,
conservation of energy.
Yeah.
Yeah. I don't know much about the energy that goes into building a tank. I never looked at that. If you want to liquefy hydrogen or even compress it, either one or both of those takes a lot of energy.
Yep.
I think I'm trying to remember some of the numbers. I think kilogram of hydrogen has 33 kilowatt hours of energy in it. If I remember right, compressing hydrogen to 10,000 psi takes something around 4 kilowatt hours per kilogram. So it's like a little more than 10% of the fuel energy just to compress it.
Right.
I can't remember the liquefaction numbers off the top of my head. So there is a energy penalty of doing that, right?
Okay.
But again, so I want to talk to you about grades of hydrogen in a second. But if everything's green, then it's just a monetary cost, not a CO2 cost.
Right.
If you actually get to zero emission hydrogen,
Yeah.
then you're just spending the money to liquefy it, not the environmental penalty.
That's a good point. Let's jump then from sea change to the offshore power boat that you guys did called FCV Vanguard, that you took essentially a speedboat, like one you'd see in like Miami Vice, and you took the V8 out of it and you replaced it with
V8s.
Yeah,
No, just one.
Just
Oh,
one.
just one?
Mhm.
Yeah, it's not yeah.
Oh, it's not
Anyways,
that fast.
so tell us, like, so how do you go, or if is it not a linear progression? Like, you went from sea change to FCV Vanguard, or was there something in between, or like, how do you go from ferry to speedboat?
Yeah, so one of the study I mentioned when I was still at Sandia looked at, what is the limit of hydrogen, and it actually found that the hardest thing to do was not the container ship, it was the really small fast boat.
Just like with cars.
Yeah.
Yeah.
There you go.
Yeah.
And part of the reason has to do with the volume of hydrogen, trying to fit that in there. The powertrain is pretty similar in size actually to the combustion engine, but the hydrogen takes up more. So this was again another grant-funded project, or there was an opportunity from California Energy Commission to build a harbor craft, not hover, harbor craft.
Okay.
Because they're looking at trying to clean up, the pollution coming from the harbor craft, not just the big ships. So we applied for that, and we said we will try to do something really hard, using kind of the government funding to help de-risk it. We're going to do the hardest thing, which is a really small, fast boat. So, and also it was a lot of fun. Like,
I love this idea. This is hilarious. You're like, hey, yeah, let's make some. This is really hard. We're going to build a really fast boat using hydrogen. Okay, that's great.
Yeah,
okay, keep going.
It's kind of like honestly, my co-founder, John Motlow, and I were just like so over dealing with really strict, very, very strict Coast Guard regulations when it comes to carrying passengers. That's like the gold standard, right? The highest level of safety ever.
Sure.
Doing all that. And then it's just kind of like, it's a ferry. It goes 10 knots. Like, what, nobody was really getting that excited about it, even though it was a really big step forward for those in the industry.
Sure.
Right.
But anybody not industry is like,
Right.
what?
10 knots.
I don't
Yeah,
care.
yeah,
right?
yeah.
So like, all right.
Yeah, but who thinks about a ferry?
No
Yeah.
one. No one thinks about a ferry. Yeah.
So what can we do that's cool? And that's one of our big missions as a company, is to try and do anything we can to make hydrogen cool. And I know it's like totally cliche, but the same thing Tesla did with the Roadster. They made
Sure.
EVs cool, right?
Right.
So that's one of our things we always come back to. How can we make this cool to get people to start associating hydrogen with things that they like and not things like the Hindenburg, right? How do we change that mindset?
Yeah. A lot of reasons you don't want to be associated with that. But
I mean, we totally lean into that anyway.
Okay.
So we decided we're going to try to do the hardest thing possible. We're going to do this project. We're going to have fun. We're a startup. We can do whatever we want, right? So let's try to do that.
Okay.
And so what are the specs? Like how fast, how much power does this thing make?
Yeah. So let's see. The power system in the FCV Vanguard right now, it's got a 250 kilowatt electric motor. So that's kind of the bottleneck at this point.
And so that's like 330 horsepower.
330 horsepower is that particular unit. If we take that engine out of the boat, and if we had an infinitely, big electric motor, I think we can get something like 360 kilowatts. I want to say out of that engine, right? Using the current battery pack and everything we have in there, because it is a hybrid.
Mm-hmm.
We have an architecture that's scalable, so we can scale that power system up to, I think it's 430 kilowatts, which is like 500 something horsepower.
Yeah, 600.
Right? Yeah, 630 horsepower, I think.
Yep.
And as you guys know, when you're dealing with an electric motor, everybody knows power and talks about power when it comes to engines, but when you're dealing with electric motor, torque is super important.
Torque.
Yeah, and same on a boat. You can just like kind of talk about gear ratios in a car. You can have what they call a higher pitch or lower pitch propeller. So if you were to have a propeller on there that's like ours is 24-inch pitch, which means every rotation moves the boat forward 24 inches. All right. So think of like a 10-inch pitch would be every rotation would only move it 10 inches, but you'd get a lot more of that kind of torque, right? So same kind of thing, because we have instant torque, 630 Newton meters, I think, at, across 0 to 4,000 RPM.
So 500 pound-feet of torque.
Yeah.
Yeah.
Because we have that at the beginning, we can throw on a pretty high-pitched propeller on there, like a 24-incher, and we can still get right out of the water, right?
Is it like crazy? I'm just trying to imagine like instant acceleration on a boat. Is it just like, Like, is it pleasant?
No, I mean, oh yeah, it's awesome. Yeah, it's like, oh, what is instant acceleration in a car pleasant?
Yes. If you're the driver,
Yeah, right.
Yeah.
But you have a lot more resistance because you're in water.
Sure.
So you never get that like whoop, 0 to 60 in 2 seconds. Like you're not going to get that.
I know nothing about boats.
Yeah.
I mean, I you know, like
So yeah,
nothing.
and me neither. In fact, I might be disclosing some ignorance here because I just tried to Google it. So the FCV, the hydrogen speedboat you built, is propeller powered. Why wouldn't it be like jet powered, like hydrojet powered?
Oh well, one of the reasons we could definitely use a jet, and jets I think are a little more efficient, especially at high speeds.
That's what. See, I didn't know that at all, but that's what. Okay, great. So
Not as good.
I also didn't know that at all.
There's a trade-off at like low speeds, but I don't really. I'm not really a boat person either. I'm really just a hydrogen guy. But
Gotcha.
I learned from my team, right? What was your question?
So why not a
propeller?
hydrogen? Yeah, why not versus a propeller?
Yeah, well, first of all, this was a 1995 powerboat,
Okay.
right? That we repowered.
Okay.
And that was part of the reason, that was deliberate decision. We didn't want to do a new build. We wanted to show that this is a drop-in replacement for gasoline or diesel engines, right? So we deliberately kept the same stern drive. So in this particular architecture, you have the engine in the hull, and then there's a shaft that passes through the transom, and there's a gearing system that goes down to a propeller. That thing is called the stern drive.
Okay.
We integrated with the existing stern drive, which is pretty interesting. It ended up being a whole nother problem because those things are really sloppily made. They're made up with a big old V8 that can handle kind of a lot of the tolerance mismatches and everything else.
Sure.
You can really abuse
a lot of Z-axis.
Yeah, exactly. But you try to connect that same stern drive up to an electric motor that has like 0.002 of an inch tolerance around it, and it's going to destroy the motor.
Right.
So we actually had to invent a new coupling that we have patent pending on to be able to connect an electric motor, super high precision machine to this really sloppy, like 4-gear bevel gear stern drive to get it to work.
Do you need gears, or you're just using the gears because they were there?
Oh, the gears, there's no reduction. There's no reduction gear. It's just basically going from horizontal here to horizontal
you mean
there.
literally geared down
Yeah,
the
that's
physical
what I mean.
boat, right?
Right,
So it's
like-
one speed.
Yes, there's the speed determined by the electric motor.
Right.
Yeah,
Yeah. I meant one gear ratio.
Mhm.
Yeah.
Yeah.
Oh,
One to one.
Okay.
Yeah.
I gotcha.
That must have been terrifying the first time you started up then, right? Like you're like, this thing you're gonna apply however much force across the system and things could just go right kablooey.
Yeah, my engineers definitely were more scared than I was. They're very, very, very conservative team, which is good.
Yeah, that's what you want. Right,
So you built this thing like at your facility, like in a dry dock. It was up, and you're putting all this stuff
It's
in.
a 27-foot boat. It goes on a regular boat trailer. So yeah, we did it all in our shop, just sitting on the trailer.
And then you fired it up dry, like in the building, and then you put it in the water. And
in stages. So
Okay.
build the engine package, have it on a test bench, and actually just using like a typical car radiator to simulate the cooling. We couldn't run it as heavy as we could getting seawater for cooling, but
Sure.
run it there, make sure all those systems are working, throw it in the boat, and actually on the bench, connect it with the battery, make sure everything's working correctly, throw it in the boat, you start doing pre-system checks, and then we actually have this giant bath, we call it the bathtub. It's I guess maybe what you see on a farm, like for watering cows. It's a really big like tub, and we just put it right at the stern of the boat and drop the stern drive into it because that's where it sucks the water in for cooling. And so we can run it there with limited capacity. And then, once we feel good, take it over the water, tie it up to the dock, run it there, really get some more power on it, make sure nothing breaks. So it's all in stages, right? And until the team feels good, we don't go out on the water. And then even the first time we go on the water, we have another boat right there with us just in case something happens. So we're pretty conservative group. We take it seriously.
When was its maiden voyage? like the real
May.
this past May.
Yeah.
And the whole project from start to finish, how long did you spend converting this 1995 offshore powerboat to hydrogen?
I think we got the grant. I want to say 2 years ago. Yeah,
Okay.
So like 18 months.
something like that.
And
So-
and how does it line up? It's actually on your website, which I should mention is zeroei.com.
Yes.
Yes, zeroei.com. It's got all these explainers. In fact, I think it's on there. How does it stack up versus the old powertrain? The new,
Right.
in layman's terms, like we're
Yeah.
not boat
Yeah,
people.
power and range.
Yeah. The old powertrain, that I think 502 cubic inch V8, Chevy big block, I think,
yeah, that's a
right?
big block, yeah.
I don't remember the torque number off the top of my head. And then, so, for 470 horsepower, maybe something like that. And as I said, ours is like 330 because of the electric motor that we could get. Again, this is like supply chain constraints. That was the biggest we could get in the time we needed. So we have less power coming out, but more torque. So what does that do for top speed? Our top speed is not as high. I think we got up to 50 miles an hour on this one, which is, by the way, sounds like a
That's
that's
really
real
fast
crappy
in a boat.
VW bug,
That's
but on
really
the water.
fast in a boat. Yeah, yeah,
Your
yeah.
original engine highlights, it's a Mercruiser 500 EFI, 502 cubic inches, 8.2 liters, 470 horsepower.
I think I got that right.
Got it right there.
Yeah.
Thanks, Ed.
Yeah.
The man
And
with the laptop.
your Z-Class propulsion system delivers 390, 522 horsepower.
No, more power.
Well, that's not what's in the boat.
Oh.
That's what I was mentioning before. That's our architecture,
Okay.
where we can scale it
got
using
it.
different electric motor to be able to. The core engine is the same,
Got it.
right? But we can do things like change the battery out, change the electric motor out, and get to that peak. Yeah.
On their website, there's a hype video that shows the FCV Vanguard going, I think, at all out, and it's just ripping across some beautiful, smooth seas. From I think he had a drone flying over top of it. It's pretty cool.
Yeah, it's fun.
Looking for the best off-road trails? OnX Off-Road has you covered. With over 750,000 miles of trails and comprehensive offline maps, you can explore without worrying about cell service. Easily find trails for 4x4s, ATVs, dirt bikes, and more. Our app provides detailed trail info, including difficulty ratings and open/closed dates. OnX Off-Road also helps you navigate public and private land boundaries, ensuring you stay legal. Try OnX Off-Road free for 7 days and discover why it's the go-to app for off-roaders. Download now.
What was the reception? What's the reception been? You get like, we actually just had a guy on. We were talking about essentially what you do, but for cars.
Yeah.
And putting EV powertrains into like old German, like Porsches and Mercedes Benz and some other fancy Italian cars, and the amount of hate
Blowback.
he gets.
Oh.
Like, when you pull up to the dock and you're putting this thing in the water, do you get people come over and say, "What's that?" Or are they like, "Whoa, that's cool"?
I've never heard of anybody turning their nose up at it. It's always been, well, that's cool. What are you guys doing?
Okay.
Yeah. And we are just, I'm down here in LA because we're showcasing the boat down here. Part of the grant funding, we have some, local funding also from people. So we're bringing it down here, showing it off. And one of the guys who rode on the boat yesterday was, he told me later, like that was his highlight of the year was
Whoa.
riding on that boat.
Okay. I gotta ride this thing.
Yeah.
What? Let me let me ask you this. When is the grant coming for a really big boat?
Yeah.
When's a container ship or similar?
Yeah. The grant, I have no idea, but if someone wants to do a container ship, we can do it. If they want to give us $100 million to build one of these, giant engines,
Give
sure.
Joe $100 million.
Okay. Yeah. We're ready. But nobody's going to do it right now.
Okay.
And the reason is fuel availability around the world. So the giant container ships are international ships. That's their purpose, right? You can't get, they use millions of gallons of bunker fuel, but
Right.
millions of gallons of fuel per fill up.
Yeah.
Right.
How much CO2 are they putting out?
Yeah, that's true. It's,
Yeah. So in other words,
3% of the world's CO2 comes from shipping, something like that.
Yeah. So
Right.
in other words, when parts of North Carolina are being destroyed by Gulf of Mexico hurricanes, like maybe we should think about this as a society. Yeah.
But it's going to take a long time to build up that infrastructure around the world to get a shipping company to say, okay, now's the time to build that ship.
China doesn't have hydrogen in sufficient quantities?
Not at the ports. I don't even know what they're doing for hydrogen production, to be honest with you, right now.
Does America have enough to to supply a big container ship?
Do
you think
we could, but we'd have to take it all,
So can we talk about grades of hydrogen? Because I think this is this misnomer. A lot of people just think like hydrogen is this green fuel, and it's like, yeah, if you make it with a solar panel, it's a green fuel. But if you're burning coal to make hydrogen or burning natural gas, it's not like there. And I don't know the terms of it's like black hydrogen, gray hydrogen, white hydrogen, blue hydrogen, green hydrogen. Could you talk about that?
Yeah. So the rainbow of hydrogen.
Rainbow of hydrogen.
Yeah. And actually, there's sort of a movement to get away from the colors and just talk about the carbon intensity, which is a metric of kilograms of CO2 produced per whatever unit of fuel used, right? But most people are familiar with the colors. So I think, I guess to kind of make a long story short, I think all hydrogen end up going to be green hydrogen, because green hydrogen is going to be the cheapest hydrogen. And the reason is fossil fuel prices are typically not going down. They're always on an upward trajectory or constant. Excuse me. But renewable electricity prices, solar, wind, is continuously dropping. And that's just CapEx. You don't have to pay for the sun. You don't have to pay for wind. So you can get solar power or something else for, 1 cent kilowatt hour produced, or even less now.
Yeah.
And use that to make really cheap hydrogen.
I know, like in Germany, for instance, they have, I forget, the number was insane, but 5 billion megawatts, whatever the number is.
Yeah.
A huge number of energy that just goes away every day. They can their generation is so much
because they can't store it.
There's nothing to do with it,
right?
And so that's why they're like BMW. They're still running around. They have hydrogen powered X5s, because they're just like we're just liquefying electricity into hydrogen because we don't know what else to do with it.
Yeah.
Otherwise it's just literally wasted.
Yeah.
Because they've become so green. Like they had a while, I forget it was a month maybe, of 100% of Germany's energy was green.
Yeah.
California I think achieved an hour or something like that.
Yeah.
But so just to your point, that's why the price will go down, because green energy production capacity keeps going up.
Yeah, and the cost of green electricity, cost of green electricity is cheaper than the cost of fossil fuel electricity.
Right.
That's what it comes down to.
Right. Yeah. You got to pay a coal
In
miner.
some cases, that's already the case. In a lot of places, actually. And then turn that into hydrogen. It's a slightly different equation. But to me, that it is going to happen, and it's going to happen pretty soon, where the cost of green hydrogen is cheaper than the cost of gray, black, whatever other.
So you're
hydrogen.
saying don't worry about the grays and the blacks, because that's just a temporary thing where we are right now as green energy takes over. And it's funny. I was fighting with someone on Instagram who was saying, EVs are just burning coal. This morning, I looked. We had a guy from Cal ISO in, and I
remember that.
And I looked at the app today, and I'm like, currently 69% of all electricity in California is from renewables. Today, as of 9:25 a.m. Pacific, November 15th.
Right.
So.
Yeah. So I think the way we look at it is you've got a crew, you've got people in commercial vessels, especially. This is their livelihood. They have to work on this ship or this boat or whatever it is. If we have the opportunity to get rid of that diesel engine, to get rid of that pollution at their workplace,
sure.
Why should we have to wait for the hydrogen supply to turn green before we do that? Like, we can do that today. We can make that boat 100% zero emission right now. And I think we should. And then we can wait and also at the same time work on greening the hydrogen, right? And like I said, I think it'll be inevitable that we.
Oh,
there you go.
you've
See,
made it.
did I get a bonus point for that?
Yes.
That it's going to end up being green hydrogen.
Okay.
And again, it's very similar with cars where, even if you're only, no one does it, but even if you're only burning coal to power your EV, which no one does, but even if you were, it's still less CO2 than burning gasoline because of EV's efficiencies. It's just that much more efficient. So in other words, even if you are burning I think natural gas is really what's used to produce hydrogen.
Yeah.
Okay, that there's some CO2 there, but eventually it'll just go green.
Right.
So we're running out of time, and I'd like to talk about because your business is not building. It's neither building ferries nor speedboats.
Right.
On your website again, zeroei.com, you have solutions, FT case and Z class. Right.
Yeah.
These are ostensibly what your startup is around. What are they? What are they? What's the business model?
Yeah. Our business model is, again, bringing hydrogen technology to the real world. So doing that in a way where people don't have to even think about it being hydrogen, and they can start using hydrogen, getting to zero emission for whatever it is they want to do. We're not so much focused on light duty vehicles because batteries have a good advantage in many cases there. So right now we have two main products. One is the Z-Class power system that we are working on adapting that out of that boat into a package for heavy duty trucking and things like locomotives and other types of commercial vessels as well. So it's just, think of it as an engine. I mean, that's all we do is we think of it as an engine. It's a combustion engine replacement. Works very similar to combustion engines. You have the need for fuel handling system, air handling system, cooling systems. It's one of the cool things. I was at SEMA last week and looking at all that, and the enthusiasts you mentioned, like, there's a little tangent here, but there's a really interesting feature for fuel cells to maybe provide some of that hobbyist experience that people are interested in working on combustion engines with, that they can't get with battery electric, but you can get with fuel cells because you have all these little things to play with, right? That being said, so that's the Z-Class, and then we have the FT case, which, as I mentioned before on the sea change, we had to invent this system to be able to fuel it with no installed infrastructure. We started getting people talking to us, asking questions once the sea change was operating. Hey, if you can fuel a boat with no infrastructure, can you fuel my locomotive? Can you fuel my Class 8 truck? Can you fuel whatever? And we kind of thought about it, said, yeah, why not? It's the same technology.
Sure.
So we've adapted that system, which is kind of the size of a sheet of plywood on the sea change, down to something the size of a carry-on suitcase that has just a simple touchscreen interface, quick connects for connecting hydrogen hoses and whatnot. So anybody, the truck driver or whoever it is with no training can go up to it, hit a few buttons, and be able to fuel with hydrogen without any installed infrastructure. So kind of bypassing that whole chicken and egg problem that is plaguing hydrogen adoption for light duty cars.
This is cool. So you go to the site zeroei.com/ftcase. The thing looks like literally from like a James Bond movie in like the 90s.
The villain would be carrying
villain
this.
would carry this, pop the top, hit the button, the world would blow
It
up.
would be handcuffed to him, and
It's like a large. It's almost like a Pelican case, like a big Pelican case size deal. And it literally has. It's got the lid and it's got some buttons and a screen on it. But you're telling me if you bought one of these things, and then you just call up your local. Is it called Rare Gas? You call it one of these hydrogen suppliers, and you got something that runs hydrogen. This thing just sits in the middle, and you connect a hose in here and a hose in there.
Yeah,
and there you go.
Yeah, exactly.
How much does this cost?
Our current retail prices, we're doing it as a hardware as a service. So the reason is it's a brand new product, and we want to be very careful because this is something, again, commercial use is always very different than retail use because reliability is key.
Yep.
So we're doing it hardware as a service. If something breaks, it's so small, we can FedEx you another one overnight, right? If we implement a new feature, because again, it's a new product like version 1.0, you get the new one automatically, right? So hardware as a service, $180,000 a year is what we're doing for that subscription.
By the way, you could have said $1 billion. We have no idea.
We have no idea.
Yeah.
Sounds
Well,
good.
like
Yeah.
I said, a hydrogen fueling station costs somewhere $3 to $10 million
Sure.
and takes you 3+ years to build, right? And so this is available tomorrow for a fraction of the cost. And there are people out there who look at it and say, okay, that's doesn't have all the capabilities of a hydrogen fueling station. It instead of fueling in 5 minutes, it fuels in 20. Like these kind of trade-offs, right?
Yep.
Other people say, I don't care because right now I can't get any fuel. So if you can get me fuel tomorrow, even if it's not 100% optimized, but it's a fraction of the cost and it's instantly available, yeah, where do I sign up?
And also the fallacy that like long haul truckers need 5-minute fill ups is like nuts. Like they eat and they do stuff.
Yeah.
So
they don't really care. And that, you know, this goes back to my time at Sandia. Like I think the automakers made some mistakes in architecting their hydrogen fuel cell vehicles that put a huge burden off the vehicle. It makes it really hard to meet.
It was all of the
demands.
end user. Yeah.
Yeah. And that they thought, okay, we're going to make this car really cool. But then what ended up happening is they shifted a lot of responsibility. How do you do a 5-minute fill of hydrogen at 10,000 PSI? Like it's a really hard technical challenge.
You need an expensive piece of equipment.
And they are not reliable. And so the experience for the consumer is not just the car, it's the car in the ecosystem. You guys have talked 100 times about charging, you know, problems, and I've had it too, my EVs, but same kind of thing. Like people won't buy it just for the car. They look at the whole thing, and that's been one of the problems that we're trying to solve.
Conspiracy theorists might argue that it was intentionally difficult to keep people into internal combustion.
No, look, that was more, I don't say conspiracy, but like, you know, you have a zero emission mandate. California, if you're going to operate your business in California, you got to sell 1,000 zero emission vehicles a year. Have at it. And so they said, okay, we'll do some that are hydrogen. But, you know, why not? But the law or the regulation didn't say you have to make it easy for the consumer. You just have to be able to lease this thing, you know, and that's and Honda and GM and the others, that's what they did. But it was, you had to go to a hydrogen station, which is still the hard part.
Yeah.
So you're solving for that.
So now
on a commercial scale.
So now I get it. So you have two products. Z-Class is literally the powertrain that is applicable to not just boats, but you're saying wheeled vehicles, trucks, awesome.
Yeah, and we've architected that to be really a drop-in for kind of that 6-cylinder diesel, you know, like a Cummins B6.7, Detroit DD8, a Cat 3126, like that, roughly 7-liter 6-cylinder diesel. It's Class 6 trucks. Port equipment, it's boats, widely used.
Right.
And then you have the fueling system that gets you the ability to fill up this powertrain. And the only missing component is you just have to call up your local hydrogen supplier and then connect the three together, and there you go.
Yeah, so that's actually that third part is we're also looking at bringing that into our business also and being able to provide that whole drop-in hydrogen ecosystem.
Cool.
We're a small startup. You know, we've got some investors, but
in other words,
we need more capital to do that.
But somebody would call you or use the app, be like, I need, you know, 1,000 kilograms of hydrogen in Austin on this day at this time, and you would say, okay, great, we'll get it there.
Well, more than that, it's more like, hey, I have a fleet of, you know, X trucks or boats or whatever that's running on diesel. I want it to run on. I want it to go zero emission. Cool. We'll come in. We'll give you the engine. We'll give you the fuel. We'll give you the method to fuel it.
Okay.
Right.
Okay.
Drop in hydrogen ecosystem. You don't have to think about a thing.
Your hydrogen as a service.
There you go.
Yeah, I got you. This is cool. So, oh man, I just lost the question.
I have a question. So this is one thing. Airplanes. I've heard a couple people have talked to me about like hydrogen powered planes. Is it feasible? Is it nuts? Like where is it just too heavy?
Lighter than air.
Well, yeah. The hydrogen, yeah.
Yes.
Does anyone think about that?
Yeah. So funny you ask. That was what I did my PhD on at UC Irvine.
Was hydrogen
for aircraft.
Really?
Yeah. So
you literally have a PhD in hydrogen for aircraft.
Well, my literally is in mechanical and aerospace engineering, but that was my PhD work.
Thesis.
Yeah.
Okay, so could you?
And I'm a commercial pilot. I have a commercial pilot license too.
Wow,
So
okay.
I was able to kind of combine two of my favorite things, 20 years ago.
Okay.
In that. Hydrogen for aviation, there's companies out there like Zero Avia who's working on this. They're starting small, and I think Boeing had like a hydrogen demonstrator 20 years ago, which is essentially a big glider with a PEM fuel cell in it. So there's been attempts at it. It seems like it's really, no pun intended, taking off right now. There's like Zero Avia seems to actually have a real system powering an actual, useful airplane that's, I think they're running off compressed gas, which is pretty amazing. Knowing they can go to liquid is going to be even better.
Right.
I think it's going to be really challenging when they start getting up to jet propulsion like type of aircraft, because the gas turbine engine is incredible. It's the most incredible piece of power generation technology in the world. And being able to match that power density that you get out of a gas turbine engine is going to be really, really hard for electric
And
aircraft.
the hard part wouldn't be the output in terms of power. The hard part would be like the fuel storage. You'd have to have like massive tanks.
Yeah, so there's a great book, I think like 1988 or something, called Hydrogen Aircraft Technology, and it's this thick, and it's got lots of detailed designs, real, not like a science fiction book, but actual of here's how you would do hydrogen airplanes, right?
Oh wow!
You wouldn't probably take a 737 and just retrofit it. You would design a new airplane from the ground up to do it, but they've shown you can do it with,
because you need more room for the storing the hydrogen.
Yeah. Have you heard of like a blended wing body type airplane?
Sure,
okay,
sure.
So imagine that, where sort of the center are these, that's where you store your hydrogen, and the people are in the wings, right? Got blended wing body. That's one example. There's others in the book, but that's one example.
Hydrogen Aircraft Technology by Daniel Brewer.
Yes, that's the one.
Shoot, it's like $600.
Yeah, it keeps getting more expensive.
Huh.
Yeah.
And then would like speeds go down? Because I'm always like,
Oh no, I don't think so.
Okay.
Yeah.
So it just be the packaging would be the tricky part.
Think of it this way: the Blackbird SR-71.
Yeah.
Right.
We think about it all the time.
So that was originally, they were trying to see if they could do that with hydrogen.
Really?
Yeah.
Why?
Why? That's a good question. I don't remember. There's a really
Scare the crap out of the Soviets. That's why.
maybe. Read the book called Skunk Works. Have you read that book?
Kelly Johnson.
Yeah, and I think he's the starter, and then the author of that book is his successor, Ben Rich.
Right.
That gets into that. It's really cool.
All right.
Really, it just seems like, I don't know, like whatever crazy fuel they were putting into the Blackbird was like, it was toxic, most polluting thing on Earth, but like really powerful.
Yeah.
Like
it's carrot.
maybe for refueling or something. Ease of refueling.
I don't remember. I got to read the book again.
Okay, yeah, I should. I have it.
I guess point being, like it's not an issue about speed.
JP7.
Right.
And look at, hydrogen is the signature fuel for NASA.
Yeah.
Why? Because it's so light. It's like 3 or 4 times lighter than kerosene. And on a rocket, every pound matters.
Really matters. Yeah.
What I mean by is lighter in terms of amount of energy per pound, right? So you can get way more energy per pound using liquid hydrogen than you can with any other fuel.
Mm-hmm.
And maybe that's why they were looking at it.
Right, because the space shuttle, the boosters were essentially you're just mixing oxygen and hydrogen, right?
The big center tank on the space
one.
shuttle, the orange one was the liquid hydrogen tank.
Right.
The two
Solid
on the side
rocket
were the
boosters.
solid. Yeah.
Okay, last question. And because we get this a lot, or we hear about it a lot, right, from some very smart people. This podcast is fundamentally about EVs, been about electric vehicles.
But the future of transportation.
We got the hydrogen guy on. You said already that for cars, EVs, it kind of batteries make a lot of sense. But some say that the end goal isn't battery electrics; it's hydrogen, or it's fuel cell vehicles. Do you believe that? Is hydrogen actually the part that's inevitable?
Oh, a good one. I think that there will be some I don't know the mix, but I think hydrogen cars will play a pretty big role, even as battery technology progresses.
Why?
Everything we just said.
Everything, no. You have to look a little bit at the history. When people started really thinking about hydrogen cars, I don't know if a lot of people don't know this. It was actually George W. Bush administration who started the whole Freedom Car initiative to do hydrogen powered cars in 2000, 2002, right? And then Schwarzenegger came in and said, we're going to do hydrogen highway. So there was a lot of work in the early 2000s around hydrogen powered vehicles. There was a lot of good studies came out of UC Davis about the best way to roll out hydrogen and fuel cell cars. Okay, now this is 2002. What was the state of the EV in 2002?
No, it wasn't no state.
EV1.
Right.
It was no state. It was after the EV1.
So nobody was thinking about EVs. They said, okay, the best strategy to roll out hydrogen fuel cell cars, understanding infrastructure, fueling is an issue, is we're going to do what they call the cluster strategy. So we're going to build a whole bunch of stations down in LA. We're going to build a whole bunch of stations in San Francisco area, and those are going to be the clusters where we have first adopters of hydrogen cars. There's going to be plenty of stations for everybody to stay kind of in that region, right? What they didn't count on was Tesla and the rise of the EV, and how the EV was now suddenly competing in the exact same market that they had planned for these hydrogen fuel cell cars. So what we've seen is sort of what's turned into sort of the best use case, what people thought was the best way to roll out hydrogen, actually the worst.
Right.
Because now they're competing directly with electric cars, which you can plug in at home. You guys know everything about it. Why would you go get a hydrogen fuel cell car now?
Right.
To travel around LA? It does not make sense.
But for towing.
But then also think about, we live in, why is California so many people live here? The climate's wonderful.
Yeah.
We don't deal with extreme cold weather or heat or anything like that degrades battery performance and all that. So if you take all that and you say, okay, we probably put hydrogen fuel cell cars in the worst light possible by starting with this strategy in this location.
Right. Interesting.
If you wanted to roll out hydrogen cars in Minnesota, traveling long distances from city to city, right? I think you would get a much different type of appreciation for their capabilities versus battery electric. And that's where I see kind of the future. The pendulum, I think, is going to start swinging back over more towards hydrogen fuel cells in these other use cases that are not ideal climates, city centers.
Because I see towing for me as I might be wrong, but okay, a lot of people now are talking, Jim Farley's talking up E-revs, Ram's going to have an E-rev. All right, you're still burning gas, which we want to get away from. But hey, hydrogen is great because then you have the torque of an electric motor,
right? And
then you're filling it up with a green fuel, an actual green fuel.
Yeah.
So is that crazy? Big dualies, big 3,500 trucks?
No, that's exactly like I said. We're going after that kind of Cummins B6.7 market, Ram 3500.
Perfect.
All those have that right in there too. We're starting a little higher, more commercial, but same idea. Yeah, those trucks need power. They usually need a lot of endurance too.
Yeah.
They're work trucks.
Right.
They need that reliability. They need the ability
towing your race car across the country. Yeah.
Yeah. Or just sit there idling all day at a job site. These kind of things. It's a really different use case that you have a harder time doing with batteries. And then you add in the whole charging infrastructure. And I'm not talking about even the chargers, which we all know is a mess, but the electric wires that transmit the electricity down the new substations. This is a
cost
hundreds of billions of dollar problem
Trillions.
now that we're trying to solve in a really short amount of time. So we can bypass all that with hydrogen. So I think the, I don't remember saying, but the demise of the electric or the hydrogen car is widely exaggerated, right?
Gotcha.
I think it's going to be different use cases than maybe where they started.
Okay. Well, awesome.
Very cool.
Well, Joe, thank you so much for coming in and blowing our minds about hydrogen.
Blowing up your minds.
Exactly. The company again, Zero Emissions Industries, zeroei.com. It's on Johnny's hat. And thank you so much, CEO Joe Pratt, for coming on The InEVitable.
And I'm gonna go on that boat next week.
All right, cool.
Yeah.
Great. Thanks, guys. It's been awesome.
Great. Thank you.
The InEVitable Vodcast, brought to you by the all-electric Nissan Ariya. Inspired by the future, designed for the now.